Good morning, dear kids. In today's class, we'll discuss few more numericals on the application of conservation of linear momentum. Let me start the class. Now, previous problem, we had the discussion about the explosive of mass m, it was at rest, no? And explosion occurs, then the fragments started moving. So now what we are going to do is like, the explosive, I'm going to throw it. I think during Deepavali festival, some of the students, they throw some very powerful crackers in air, no? And in the mid-air, the collision will occur. Similar to that is what we are discussing here, the numerical. It breaks into fragments. Analyze the motion of center of mass in different cases. So here, there's a thing. So we'll analyze one by one all the different situations. First, I'm going to the first case. There's an explosive. I'm going to project with a speed u. All these are very simple. Huh? It's not that tough any mathematics. So now if there were no explosion, it would have just continued its trajectory. If there were no explosion, the explosive what happened would have continued its trajectory and it would have landed at a distance at a range r. What is this r? This r is equal to u square sine 2 theta by g. This would have been the range. No explosion occurs. Okay, somewhere in the mid-air. Here we'll take it. Here definitely it will have some velocity. And due to explosion, so what will happen? So it cannot have the same speed. I think you know projectile motion now. So let's analyze like this. So it in mid-air the collision will occur. I'll take help of diagrams, so it'll be easy to express that idea. So mid-air collision will occur. So due to collision, so what will happen to the fragments? The fragments, one fragment, the other fragment will show it. So what are these? These are the fragments. Now what actually happens is one of the fragment will trace out a path like this. Will land here. So will land beyond the launching point. The other fragment where it has to land. In mid-air the collision will occur. And it will break up into two equal fragments. So m by 2, m by 2. So this will have some velocity, say v1, v2. And what is the trajectory of this? The trajectory of this, it has to be in this way. Where it has to land here. So now let's come for this one. Due to explosion, what are the forces that are acting? They are internal forces. And we know due to internal forces, center of mass will not shift. So now, what is this dotted line? So this will be the trajectory of center of mass, as if the center of mass will move as if there is no explosion. The center of mass will move, it will continue its path, parabolic path. Where do center of mass will go and strike the ground? At a distance r. Means what is this? This one is the path of center of mass. The center of mass will move as if nothing has happened. It will go and strike the ground at a range r. One of the fragment will go and land here. So let this be distance r by 4. Where the other fragment should be, because the center of mass will come and strike here. So now m1 x1 should be equal to m2 x2. So if this is x1, what about the other fragment? Other fragment should be at a distance x2. The diagram may not be up to the scale. m1 x1 equal to m2 x2. So both are of equal mass. So here No. Okay, the other fragment will land here. What is the mass of this? This is m by 2. Masses are same, no? So here m1 x1 equal to m2 x2. This is m by 2 x1 m by 2 x2. So therefore x1 equal to x2. What is x1? We know x1 from the diagram. R by 4 plus r is equal to x1, which is equal to how much? 5r by 4. So from this particular point, at what distance it will be? It will be at a distance of 5r by 4 from the center of mass. From the launch point, it will be different here. So what is this distance now? This x2. x2 we should write it as 5 by 4. From the launch point, if one of the fragment at a distance r by 4, what about the other fragment? The other fragment should be at a distance of r plus 5r by 4. How much it will be? From the launch point, so what is the distance from the launch point to calculate? R plus 5r by 4. Like this it is going to land here. So like this, if you know one of the fragment where it lands, we can predict where the other fragment will land. That's one of the sequence. So like if they don't break up into, if they break up into unequal fragments, it can happen. If they break up into unequal fragments, then what conditions will come? I'll go for the next situation. Just analysis, see, just analysis here rather than some. Okay, this is the center of mass of will land here. It is projected with a speed u at an angle theta. Unequal fragments, one of the fragments, somewhere the explosion somewhere will occur here. I'll just show it in this way. Explosion will occur. Then due to that, m by 4 will come and land here. At what distance? Say like a r by 2. What about the other fragment? Where do we expect? And we know this should be the r by 2. If m by 4 will mean, so the heavier fragment will be here. 3m by 4 should be there, no? So can we predict this distance? So now this distance should be the x1. Again, there's a second case. So what is the formula now? m1 x1 equal to m2 x2. So here what is m1? m1 is m by 4 x1 x1 equal to 3x2. So what is x1? x1 we have idea from the diagram. R by 2 plus r by 2 plus, or let it r, 3r by 2. x2 must be 2r. R by 2, sorry. So O will be always, the heavier mass will be near to the center of mass. The heavier mass, suppose it was green color, no? No, O will be the near to center of mass. The heavier mass will be near to the center of mass. See. So if you know position of one of the fragment, the other fragment where it is we can predict. If you know the heavier fragment, you can tell where the lighter fragment is. Sir, can it happen like this? Yes. Even instead of falling beyond, it may happen here. If it falls here, then if you know this distance, you can predict the other fragment where it will be. The explosive can break up into two equal parts or unequal parts. It's not that the fragment should be of equal mass. Need not. It can be of different mass also. But what is there? There's a path of center of mass. Though explosion occurred, here explosion, the center of mass will continue its parabolic path. Any reason for that? Due to explosion, the internal forces will act. Internal forces cannot accelerate center of mass. So in what direction the center of mass, because of the projection, how it should move, it will continue to move its in trajectory. Okay, no object will move here. Sir, is there any mass will move in this direction? Nothing. Center of mass will move in this trajectory. Parabolic path, it will continue. The other objects, it will go like this. Now, what are this red color and this one? This is the trajectory of I think this is very important. You should know also this trajectory. How do they will move like this here? Okay, this is about some basics of the center of mass here. Now, during explosion, so we'll fill up some chemical energy. I think you can see that during the Deepavali crackers, you'll get a sound, you'll get a lighting. So if I project an explosive, I'll project with a speed u at an angle theta. Somewhere at highest point, it is going to explode. It is going to explode here. So one of the fragment, if it moves in this direction, here explosion occurred. Okay, due to explosion, two fragments have come. So whatever the other fragment, how it should move. It occurred at highest point. The center of mass will continue as if there is no explosion occurred. Am I right? No. There is a path of center of mass. If one of the fragment moves like this, whatever the other fragment, how it should move. Momentum should be conserved. The other fragment you cannot put horizontal. The other fragment should have velocity in this direction. If this is theta 2, this theta 1. At highest point, what is the velocity mu cos theta? Just before explosion, it will have horizontal velocity how much? U cos theta. Then what are the equations you are going to write? Net external force on the system along x-axis 0. So momentum is conserved. So initial momentum mu cos theta, mv1 cos theta 1, m2 v2 sin theta 2. Along y-axis also, the net momentum is conserved equal to 0. So you can write conservation of linear momentum. So initial momentum 0, final momentum m1 v1 sin theta 1. Like this, you can apply conservation of linear momentum. But if one fragment is having velocity upward, the other fragment cannot have horizontal velocity because momentum has to be conserved. So the second fragment should move in a plane. That's the first case. Here explosion occurs. Explosion occurs at highest point. Okay, there's the one condition. Then okay, now during explosion also some energy will be released here. So if I put it mu, what is energy released? M. Initial kinetic energy just before explosion, plus some energy will be released, E naught. So what is E naught? E naught is, we'll write it here, E naught is energy released during explosion. Okay, this energy released, it can be in many forms. If the total energy converted into fragments means what you are going to do, you are going to write equation like this: mv1 square by 2 m2 v2 square by 2. So here what happened, the whole energy is converted into kinetic energy of the energy released is converted into kinetic energy of fragments here. It can happen half of the energy is converted into, half of the energy released is converted into kinetic energy of fragments. Remaining of will be converted into sound. I think in Deepavali crackers, when you throw cracker in air, in mid-air explosion will occur, no? The cracker will get blast. So what actually happens? We'll get a sound also, no? And also we'll get lighting also from crackers. Then what happened there? The energy released, a part will be converted into sound, a part will be converted into fire, the remaining will be converted into kinetic energy of fragments. It all depends upon, if I put a condition, the whole energy released is converted into kinetic energy of fragments, means you should write equation like this. Half of the energy released converted into kinetic energy of fragments means you should write E naught by 2. Where do remaining of gone? Can be sound, can be fire, whatever be that. So there is no rule that the whole energy should be converted into kinetic energy of fragment. If I say that half of the energy released is converted into kinetic energy of fragments means you should write E naught by 2. I'll put that by 2. So what is the energy released during explosion? So what I'll put a condition is that let half of energy released during explosion is converted into kinetic energy of fragments. Then I'm able to write this off. Otherwise, I should not write off.
Sir, M2 V2 cos theta 2 should come. Sir.
Yes, sir.
Oh, kinetic energy, how it will have the direction, my dear?
Sir, in mu, in delta fx equal to 0, one equation you wrote, right, sir? There, sir.
M2 V2 cos theta 2.
Oh, here, momentum.
Yes,
Okay, yeah, fine. Yeah, thank you.
Sir, and delta fy equal to 0, how did you do, sir? Gravity is acting, no, sir, external force.
Explosion will take for 1 hour. Deepavali cracker not burnt.
Sir, at that instant you are doing, sir.
Yeah.
Okay, sir.
What is the explosion? Will be fraction of time, no?
Yes, sir.
And what is the change in momentum due to gravity? Nothing will be there. The internal forces will be very much greater than gravity. So therefore, the change in momentum, what all occurs, will be due to internal forces, not due to gravity.
Yes, sir.
Okay, now so these are the conditions they'll put it. If there is no energy released, okay, nothing. You can just add up here. But most of the explosives, there will be chemical energy will be available. That will be converted into kinetic energy of fragments. Now, if one of the fragments move vertically up, what can happen? How the others should move? There's the next possibility.
vertically down it should move.
Yeah, yes, see, I'm just picking up one more page. Here only I can minimize. So yes, student, I'm just wanted to give that idea of conservation of linear momentum, how you can apply that conservation of linear momentum in various cases. There is the primary focus here. The discussion is all about that one. Okay, next part. Explosion will occur, and the explosion may take place in such a way that if one of the fragments, if it just moves vertically up, here half of the energy, 1/4 of energy, I'll put it. How the other fragment must move not vertically down, it should move in a plane, because initially there was momentum along x-axis. Okay, fine. Final momentum along y-axis should be 0. So therefore now what is the equation you are going to write it? How the equations? So net force along x-axis 0. Initial momentum mu cos theta. Final momentum. That's all. Then net force. Momentum is conserved in any direction. Here just we are picking up x and y. 0 initially. So final momentum mv1 m1 v1 minus m2 v2. Okay. Then what is the? It's telling 1/4 of energy. You should write in this way. So how to predict that if one of the fragment, if you know how it moves, Unnati, class. If one of the fragment, if one of the fragment, if you know in what direction it moves, the other fragment in what direction it moves, we can predict here. Where do it land also we can predict. So here it will go and land somewhere here. I think I'll draw the trajectory properly. So where do the trajectory will come like this. The other one will land here. Okay, no, so there are sameness. Even if it, one of the fragment, if it moves like this, the other fragment has to move in this direction. Okay, that one. So you may get wide varieties of questions here. A student has to take help of this one. It may happen that both the fragments after explosion will move horizontally also. It may need not to explosion need not occur always at highest point. It may occur here also. I just gave one of the examples. Now this is very important, sir. Energy is what to do. It will be available as energy of the fragments here. I think conservation of momentum is very important. How to predict the path of the other fragment, both the center of mass, because if first fragment, where do it will land? It will land here, no? The second fragment, will it land here? No, it should land here. So what is the region? Here, second fragment will land. The first fragment will be here. Center of mass has to be here, no? If the center of mass has to be here means, so where the landing point of M2, we expect M2 to be here. And we'll expect M1 to be here. M2 cannot be here. Center of mass here, M1 and M2 cannot be here. So a student has to make a guess of all the available things. A good number of questions can be asked. So take help of all the basic things what you know.
Sir, after explosion, can they move in horizontally opposite direction, sir?
Yeah, they can move also in opposite direction. I'll bring one more situation. Anything, let them move in whatever direction they want. You apply conservation of linear momentum, that's all. Okay, I'll bring one more. It can happen. Let's keep it here. It can happen that this V1 let me adjust this. Explosion occurs here, and after explosion M1 and M2. This can also happen, and the trajectory of this. So many possibilities are there. I think it's like just let me generalize it. We can't keep on draw the diagrams. So many possibilities are there. Altogether, momentum should be considered in all directions. So usually we prefer X and Y. Easy for us to analyze here. Okay, this is M2 and this is M1. It should not land here. No, it's going to land here. Then what is the expression? Here one third I'll take it, or total energy is converted. Total energy released is during explosion is converted into kinetic energy of fragments. So what are the equations we'll write here now? Apply conservation of momentum again. Here's what the explosion. It will explode here. So conservation of momentum. M1 mu cos theta equal to M2 V2 minus M1 V1. Then m by 2 u cos theta whole square plus c naught, no? One very simple explosion is internal force. During explosion, internal forces will act. Finish over. That is enough. That is only teacher should tell. Any possibilities can happen. So based on the conditions given, now you are going to write all the equations. Okay, this is very important. Can be asked in, because some projectile is mixed with center of mass, so all possibilities of asking. Instead of throwing horizontally, I may throw this explosive vertically. I may throw this explosively from the tower, from the inclined plane. So it's unlimited, no? Just carry on. There's nothing called like a, should be asked like this only. There are several ways of testing a student. Let's go for the other one.
Sir,
Hmm.
sir, can we take the he naught as he naught by 2, sir?
It all depends upon condition. What it gives. Half of the energy released, you take E naught by 2.
Oh, okay, sir.
Now, this is a very, very beautiful problem. Some good concept is there here. Now, already we did so many problems like this. In laws of motion, I brought it. In the friction chapter, we included all this one. Now, these are the two blocks. Initially at t equals 0. Okay, this is a smooth surface. I'm going to project with the velocity, the block and the plank with 6 meter, 2 meter per second. It's asking, find the final velocity of the plank. I think we know, like here the friction will act here. The friction will act here. Then finally, what are the sequences that will take place? Some very important concept is available. That is what I'm trying to stress here. Otherwise, we know how to calculate that common velocity. Let me bring this. So after some time, then when they attain common velocity, all of you please do make observation. This is very important for as far as learning is concerned, I feel. Okay, this will have some velocity v1, this will have velocity v2. Then again go and check it, v1 greater than v2. The friction will continue to act, and because of friction there will be relative motion. Okay, this will undergo retardation. We have discussed everything, all this one, and this will accelerate because of friction. And finally, they will move with a common velocity. Once they move with common velocity, no longer friction will act here, and no slipping occurs. I want that common velocity. Can you apply conservation of linear momentum? But friction is acting. Can you apply? We are not bothered like who is acting, which force is acting. Net force along x-axis, 0 or non-zero? 0. So you can apply conservation of linear momentum. So it's nothing to do with conservative force, non-conservative force. Momentum is conserved. Momentum is not bothered about nature of force. Momentum is bothered about only net external force on system, 0 or non-zero. Plus F minus F. Net external force is 0. You can apply conservation of linear momentum. I think very important. Usually we have some impression that friction acts, momentum should not be conserved. No. We are not bothered like a friction acts, tension acts, normal contact, whoever let him act. Net external force 0, momentum conserved in that direction. In which direction net external force 0? In that direction momentum is conserved. Now the problem will become very easy, no? So what is the 2 into 6, 3 into 2 equal to 2 into V, 3 into V. Anybody can do this? See this? Very simple, no? Or else what you should do, same problem we did in friction chapter. Go and check it. We have struggled a lot to bring this particular answer. After getting V, can you calculate time? Yes, you can work out all. Okay, sir, momentum is conserved along x. So is it Energy is also conserved. These are very fundamental questions. Huh? Is it energy also conserved? Is it initial kinetic energy equal to final kinetic energy? The answer is no. You go and check it, final kinetic energy, it is less than initial kinetic. Where did that energy gone? Work done by the friction. Sir, momentum conserved, and you are saying energy not conserved. Because net work done by friction is non-zero here. So how to calculate that? So you know final kinetic energy, you know V everything. So initial kinetic energy, work done by friction equal to final kinetic energy. Initial kinetic energy. These are I'm suggesting you. These are some very best problems. Huh? Okay, this will be 2 into v square by 2, 3 into
Sir,
v square
3
by
into 2 square, sir.
2. Mass is 3 into 2 square. Check it, work done by friction will come negative. So net work done by friction, what is F? The friction does negative work here because kinetic energy of system decreases. Sir, momentum conserved, then you are saying energy not conserved, kinetic energy. Yes, it can happen. It all depends on the situation. You can't just put a rule everywhere that if this is conserved, this must be conserved. Nothing to do. Momentum is not bothered about the nature of force. Mechanical energy conserved or not conserved depends upon which forces, nature of force. This is the primary thing which is very, very important. Only through numericals will get it. Just read textbook. Tell me where it's possible. Until unless you don't think, analyze numericals, physics clarity of concepts not possible. So only through numericals only what happen. You are in a better position. Just mere reading theory. You have everything this is there in the SC Verma. Theory is there. Yes, he stresses this. How many of you will understand? Nothing, no, highly impossible. Until unless you don't do numericals, no, not possible. Now with the spring force we are bringing. Already we have seen one more just simple. What we do is like we are going to initially they're at rest and I'm then going to pull them apart. Okay, now look at this one. Stretch it by length x naught and the spring is stretched by x naught. So when I stretch it, so this is okay. I should go for till here. No? This is. So what is the elongation of spring? No, x1 plus x2 is the elongation of the spring. Now how much of spring force will act? Kx will act, not kx1. Very, very important. This end is displaced by x1, this end is displaced by x2. So what is the total elongation of spring? X. What is x? X is the elongation. So sorry, this x naught is elongation. So now don't write kx1, kx2. No, not like that. Kx only should be that. So now this force, what it will do? These are released from rest. So again, when the springs come to the original position, when the blocks come to the original position, what spring force? Spring force, in fact, did work. No, spring force did work. So when the force acts, the body will accelerate. Due to acceleration, speed will increase. Due to increase in speed, increase in kinetic energy. So now these will have velocity v1 and v2. We have to calculate that v1 and v2. That's what the question. Find the speed of the blocks when spring is relaxed. So again, what is the state of spring? how to calculate that V1, V2. Who is the force doing work? Spring force only. Can we apply conservation of mechanical energy? Yes, it is. Then what is the net force on system along x-axis? 0. So initial momentum equal to final momentum 0. So m1 v1 minus m2 v2. Then kx naught square or kx square should be equal to m1 v1 square. So mechanical energy is conserved. So what is this? This what I am writing is conservation of mechanical energy. So previous problem you didn't apply, now you are applying it. Because what is this spring force? Conservative force, no? Yes, we are able to apply. If there is any kinetic friction acts, you cannot apply this, but you can apply. If the friction acting on both the blocks is kinetic and equal, this friction equal to this, you can apply this, no problem. But you cannot apply this one. So momentum is not bothered about nature of force. Momentum is all about net external force, 0 or non-zero. In the direction in which it is 0, in that direction you can apply it. This is what a student has to make observation here. V1, V2 or two unknown things, solving will get the required answer. Now what will happen to center of mass of system here? Suppose m1 greater than m2. We'll put it. Center of mass will lie near to the heavier mass. Anything will happen to center of mass. So center of mass will be there only. This is the most important thing student has to make observation. So where the center of mass will not shift. You can see the vertical line. Okay, are you getting now? So center of mass. Why it will not shift? Net force along x-axis 0. The blocks will be oscillating, but center of mass will not move. There's unlimited problem. There's the best topic I'm telling you. You have to work out numerical, different. That too diagram based, not some math based things. Please avoid all that one. Whatever be the weekend exam, don't bother. Learn this particular topic, center of mass, conservation of linear momentum. There's one more. All surfaces are smooth. The system is released from rest. Find the maximum speed of the wedge. There's a wedge, there's a block. He's asking maximum speed of the wedge. So there's a curved part. Are you seeing the wedge? I made some curved track. The moment I release, the block will start moving like this. Then, what are the forces that are acting? Normal contact. I think I'll make diagram small because I have to draw plenty here. Somewhere the wedge will undergo some displacement. Why it will undergo some displacement? The block will be here, no? M1. So it will having some velocity, say V1 dash. This will have velocity V2 dash. What are the forces that are acting? Only let me show the normal contact. N1 on the wedge. N1. Then the velocity of the wedge should be like, why the wedge should move back? Because of N1 sin theta, and there will be also the weight will be acting. And the normal contact from the ground. Okay, let's have this one. The weight of this also will act. show all the various forces that are acting. Now, net force on the system along x-axis, 0, no? N1 sin theta, N1 sin theta. Net force on the system along x-axis, 0. So therefore, the momentum and the center of mass will not shift along x-axis. What about y-axis? As net force is non-zero, center of mass will shift along y-axis. This much is there. And now, what is the state of the wedge? Why it will move back? Because of N1 sin theta. Finally, now, what is the next part of the problem? We have lost such students who really draw diagram and solve the problem. I'm telling you very clearly. We don't have students. First of all, students don't have patience. Sir. Absolutely nil. Question, answer. Question, answer. Don't want to learn. They want to become clerk or accountant. Nobody wants to draw diagram, free body diagram, analyze. The moment you see question, answer should be there. The moment you see question, answer. There is a reason why you are landing in this trouble. Earlier, students used to learn less number of problems. Do you think that? I think till 2005, I know students, they used to spend only with SC Verma. I need these are the two books, finish out. No other book. And exams, you know, like only in a year, their maximum monthly one exam. Grand test, some 5 grand tests. They were very good in knowledge. Now, weekly 3-4 exams. Teacher is teaching hundreds of numericals. Helpless situation. What is the reason there? The students are not doing the problem complete. Just only 10% they're doing. How much is there in book? Okay, find velocity. Okay, velocity. What will happen? Everything. There are so many things are there. No, if this is rough, anything will happen. If this is rough, anything will happen. How do you analyze? Very openly, I'm asking this question very openly. You may get hurt, but the reality is what I should speak. If this is rough, what will happen? If this is rough, what will happen? So many things are there. No? How come this problem is over when you get answer? If there is some like a groove is there here, then what will happen? Or if this part of the wedge is removed, then what happen? It will fall. Unlimited, no? The students what happen? After reading question, they used to analyze all the cases. Okay, there was a completeness of the knowledge was there. Now what will happen? Solving thousands of questions, still no clarity. The reason for that, just if question is there, you know how to think. On your own, you don't know how to analyze. This is a very dangerous path. Okay, I got this velocity. Now what will happen? Okay, is this maximum velocity? Because he's asking that maximum velocity. Because what is the question asked? First we'll get the answer. Okay, this need not be maximum velocity. Now further, the block will start moving up now here. The block will start moving up. As it starts moving up, what will happen to the velocity of the wedge?
It reduces.
It starts decreasing. It starts decreasing. And where do it will come to rest? It will come to rest at highest point. And what is the state of wedge? Wedge will be at rest. So next sequence, what will happen is like so many diagrams. What do you expect? The wedge should be at rest. Okay, and the block will also come to rest. For a moment, it will be at rest. Instantaneous IR. IR means instantaneous rest. Then again, what will happen? Again the wedge and again the block starts moving again like this. The block and the wedge will be oscillating. So what is the maximum velocity now? This was the maximum velocity. This V2 is what maximum. Are you getting? This V2 is what the maximum velocity. How to calculate this V2? How to calculate that V2? Applying conservation of mechanical energy. M1gr equal to, okay, this like this. I'll get the V1 and V2. Two unknowns are there. I need one more equation. Conservation of linear momentum. Initial momentum 0, final momentum, and this V2 is in fact the maximum. Okay, we have to analyze the situation. Anything will happen to center of mass. Center of mass will not shift. I didn't draw a diagram properly, but the center of mass in fact will not shift. Whatever happens to the block, how they move, let it be. Where the center of mass of system, it has to be there only.
Sir, it will move along y-axis, no, sir.
Along y-axis it will move.
Yes, sir.
Now the same problem, I'll give some small twist. Let's see that how you think on this one. I'm really testing my students. Let's see that how well they can analyze the situation. Let's see that how you think. There's a wall, I think. Okay, there's a wall. It's a wall will be usually fixed. Wall means will not move, no? So I want the maximum speed of the wedge. I think within 3 minutes you can really break up. 3 minutes is sufficient because already just now I gave the basic idea. As the block moves from A to B, B to C. So let's see that. A, B, C. When the block moves from A to B, the wedge wants to move towards left. But the wall will not permit, no? The wall is not going to permit. No, the wall will not permit here. So then what will happen? The block which is there, it will land at the lowest point. It will come here. The wedge actually wanted to move, but the wall what happened will not permit. So it will acquire a velocity u. Now what will happen? As the block starts moving, as it starts moving from B to C, normal contact on the wedge will act towards right. So what do you expect the wedge now? Wedge will start losing contact. So as the block is climbing up, this will be the situation. Normal reaction N1, N1. So the block will have some velocity V1, V2, VR, I'll write it with respect to wedge. Now why do the wedge will move? Because now the normal contact N1 will act, N1 sin theta. It will make it start moving. Now anything will happen to the block. Where do it will come to rest? It will come to instantaneous rest. Somewhere the block will come to instantaneous rest, and both will have common velocity. It will write to certain height. It can, will it reach C? Anybody wants to answer? So why you are not bringing this at C? Why you are showing it below? I want answer from any one of you. Why can't it? Why you are not showing it here, sir? Like why you are making it? Why it is
So
the
the
block?
wedge is moving towards right. So
Yeah, if the block reaches here, you see that one, the energy will not be conserved, because from where this has come, the block has slided from here, no? So if you show this block here, you compare with this, the energy. So this additional kinetic energy of the wedge will become additional, not possible. So energy will not be conserved. So therefore the block M1 should not reach to the point till C. Next, after this, what will happen? It has come to, for a, with respect to wedge it will be attached, with respect to ground both will be moving with common velocity. Now it will start sliding back. Again still normal contact will act towards right only. The next sequence of the diagram. I can't show below, I'll show it beside. So here, there's a better way. Some velocity, it will be some v dash you call it. Finally now you see the n sine theta, the normal reaction. So this n sine theta will further increase velocity, and what we can clearly say this v dash greater than v. Next sequence, what we get is like, there's a maximum velocity. And the block will be, how come you say, sir, this is the maximum? Let me write V2. Some diagrams. Place is the biggest problem. Yeah, I think this will be sufficient. So I'm going to call this as maximum. So how come you can say that is the maximum? Maybe when the block again starts climbing up. So again it starts climbing up. How n sine theta will act? The n sine theta will act towards left. That will decrease the velocity. Now this is the maximum velocity. If you want to, you have to draw one more diagram. I don't have patience. I don't have place here. Sorry, not patience, place here. V dash, this is some n1. So now again the block starts climbing up, and n1 will act in this direction. So it will retard the motion. It will decrease the velocity of this one. So this is the maximum possible velocity of it. We have to calculate this. That was the question. How to bring that one? You know most of the basic concepts now. You know all the concepts. How you are going to bring. Can we apply conservation of linear momentum? Yes, you can apply. From which diagram? From diagram 1 to last diagram. I want comments from students. From between which diagrams we can apply conservation of linear momentum? I think from here, no?
from
Because first
second
diagram you should
diagram.
not apply. From second year you can apply it. What is the state of wedge? Wedge is still at rest. Now after the second diagram, second situation, it starts moving, no? So I can apply conservation of linear momentum. Net force equal to 0. So m1 minus the V2 is maximum. I'll write it here. Then can I apply conservation of mechanical energy? Yes, it is. that you need not to bother about all this intermediate. If you want to calculate to what height it will rise, you can go for it. Already we have done. I'm just interested in maximum speed of the wedge. Now the speed of the wedge will be maximum. That n1 sin theta plus n1 sin theta minus n1 sin theta. Net force is 0, therefore we are applying conservation of linear momentum. This is the last one. Let me share only the idea. This surface is inclined plane is rough. The block is laid from certain height h. This surface smooth. He has given the mass of the block and the wedge, the angle of inclination, the quotient of friction. The system is laid from rest is telling. The system is laid from rest. Find the velocity of block and the wedge when the block reaches the bottom of incline. And is asking find also the acceleration of center of mass. Of system. I think this will be really little bit challenging for students. So, but you have come across this where you are come across in the laws of motion chapter, similar problem. Only thing is friction is what I introduced here. So what are the various forces that are acting first? M1G sin theta. I think it's all about first free body diagram. This is N1. M2G, normal reaction from the ground. And N, let me write it here. How the friction on the block, on the wedge, you have to show it here. Now, net force by the on the system along x-axis, n1 sin theta, n1 sin theta, of course 0. So we can apply conservation of linear momentum, but we can't apply conservation of mechanical energy. Any reason?
Non-conservative force friction is acting.
The friction is acting.
Friction is acting.
Because of friction, we can't solve the problem. But he has asked how to find out the velocity. For that, what happens? You should calculate the acceleration, then what distance it has moved. From there, you have to get into the picture. If this was smooth, okay, then go for conservation of linear momentum and conservation of mechanical energy. Momentum is conserved, there's no problem with that. But what is the problem is mechanical energy is not conserved because of friction. Okay, sir. Okay, how to do that one? So we know this will accelerate. I'll do one thing. I need two diagrams. No. So accelerations will show it. Let's keep that diagram, original diagram as it is. Here we'll show all the things. Now getting to thing. Already we had such discussion in the laws of motion chapter. Now the acceleration of the block with respect to wedge AR, acceleration of the wedge BA2. Then I should bring a pseudo force. Why pseudo force? Because we are describing the motion of the block with respect to wedge. What is AR? AR, we are assuming it. Acceleration of block with respect to wedge. And then what are the equations of motion we can write it? First of all, what is normal contact is needed. So this N1 plus M1 AR sin theta minus m1g cos theta equal to 0. It's a good question for learning. Lot of things are involved. Okay, we got n1. Then let's write some equations of motion for the motion of the block along the incline. For block along the incline. So what are the equations are right? m1g sine theta plus m1 ar cos theta minus friction equal to m1 a2. Some correction is there. Here. I think. And that's a pseudo force one. I'll show it separately. Okay, no. M1 A2, no, pseudo force, not M1 AR. No, symbols. This one. Okay, this is our equation. What is F? F equal to mu N1. N1 equal to M1G cos theta. Okay, then this is for the block. Next, for the wedge, we'll write equation. Just it's a patience, student. Will such numericals, what happen? You are going to learn multiple concepts. You are not one, two. That's the advantage. Now look at the wedge. What is the force? N1 sin theta will act. Then on the wedge, F cos theta. Friction also you have to show it here. F cos theta, N1 sin theta. What is F? Mu N1 cos theta. Now here N1. What is N1? N1 we have from the formula M1G cos theta. These are the equations. These are some primary equations what we have, keeping it. What are unknown things? I think we got expression for A2 here. Am I right? You can check it here. I got expression for it. That A2 I'll substitute here. I'll get AR. It's very lengthy. I gave the values, so we could have substituted values and solved it. Okay, I got this one. So now what should I do? From equation 2 and 3, what are unknown things? AR and A2. Yes, we can solve it. After getting A2, then I'll come into the picture. What is AR? AR is the acceleration of the block with respect to wedge. I am asking you acceleration of center of mass. So what is needed for you? Acceleration of this block along X, along Y. How to calculate acceleration of block with respect to ground along X, along Y. I'll take help of relative velocity. So if this is the block, E2, that's all, no? Here, what we can write here, because what are the forces acting? This is very important. N1, friction, the friction. So in simplest thing, can we write here like N1 sin theta minus F cos equal to M2 A2. N1 sin theta minus F cos theta equal to M2 A2. Similarly, N1 only, symbol N1 sin theta minus F cos theta equal to M1 A1x. Are you looking at the motion of the block? So therefore, from here, what I can do now? M2 A2 in fact equal to M1 A1x. Do we know A2 there? Yes, I have A2. Okay, there's a problem solved. How to, after bringing A2, then you are going to bring the A1x also. So what is A1x? How to bring A1y? AR sin theta. I think from AR is what you have calculated. So A1y should be equal to AR sin theta. Then what is the acceleration of center of mass? You are going to write now M1, M2, A2 bar. You see very interesting things will land up. Minus this will be plus M1 A1x I cap plus M1 A1y minus G cap by M1 plus M2. M2 A2 is equal to M1 A1x. Already we have this equation. So substituting that, finally which is equal to minus M1 AR sin theta, because what is A1y? A1y should be equal to AR sin theta, J cap by M1 plus M2. So what is AR? AR is from here only we had. Substitute that, you get the acceleration of center of mass. So how the center of mass will move? It will move vertically down here. Though the block and wedge are moving horizontally, the net displacement of center of mass is along y-axis only. Even let there be a friction, with friction you can manage here. There's like a very important students here to learn things. I brought it here. Okay, after getting acceleration of center of mass, how to calculate the velocity of the blocks when reaching it, because you know it will descend an height h. Remaining all you can apply it and calculate the things. How to write various equations, and finally look at the, because the net force on the system along x-axis is 0, that's why the center of mass will move only along y-axis. And what is that? This M1 M2G. Normal contact is also acting. You see that F sin theta, N1 cos theta, N1 cos theta. This is unbalanced forces there. That's why they said M1G, M2G and N. This F sin theta will nullify. N1 cos theta, N1 cos will nullify. But M1G plus M2G minus N will become unbalanced force. That's why center of mass will accelerate. So what is the conclusion in this problem now? What is the conclusion? Net force along x-axis 0. That's why the center of mass will shift down. So earlier it was here, somewhere here. After some time when the block reaches bottom of incline, it will come somewhere here. Any doubt if you have here, you can clarify it. You have to substitute all the values. I just gave only the basic idea. So I think let's not bother how to solve such numericals approach. First, read the question, understand what all he has given. Show all the forces are acting. Under action of forces, how do they move? Then once again go back and read question. What he is asking? What are the known things? What are the unknown things? Then how you can write the equation. So what is the, again, very essential conservation of unit of center of mass? Free body diagram. Show forces acting on the system. What are all forces acting on system? And check net force 0 in what direction. Conservative forces, non-conservative forces. Can apply conservation of mechanical energy. Can apply conservation of Newton. Like that is what happens. Student has to analyze here. Shall we call? Yeah.
Sir, here, why are we not taking AR, sir?
Where AR?
Sir, relative acceleration of block with respect
That
to its
that only I did know. Where you are looking at the screen, what is AR? AR is acceleration of the block with respect to wedge. In all the equations you have no.
sir in the acceleration of COM, sir. There,
This one, huh?
yes, sir, yes.
AR is there, no. Yeah.
Okay, sir. Okay, okay.
Open your
I didn't see,
eyes.
sir. Okay, sir.
Okay, I'll end up the class. Okay, kids, like you have seen, no? It's all about now. Read the question, show all the forces are acting, and under action of forces, how do they move? Then go back, read question. What is the unknown? What is the known thing? Then what are the ideas you can apply? Conservation of in what action you can apply? Conservation of mechanics, can you apply it or not? Then applying the laws of motion equations. Then if forces are constant, equations of motion. Forces are variable, then the integration. There's overall, I think the almost all the ideas of the mechanics, what you learned, you are going to apply that in a phase-wise year. Kinematics, then the F equal to ma, then if there's friction is there friction, then work done. So many things will come. Hmm? So please do analyze all this one, very very essential. In every problem, work done by all the forces you have to analyze. In what action I can apply conservation of Newton? Can I apply conservation of mechanical or not? What is the type of motion it's describing? How to write that equations of motion? All this stepwise it should come. Okay, thank you all of you.
Thank you, sir.